1 by n of summation of yi minus y bar whole square. Covariance of xy is equal to 1 by n of summation of xi minus x bar into yi minus y bar. So to calculate the covariance matrix, we have to find three things. One is sigma x square, sigma y square, and covariance of xy. In second step, eigenvalues can be found by using the det of a minus lambda I is equal to 0. Third step is we have to find the eigenvectors. Eigenvectors can be found by using a minus lambda I into x is equal to 0. So here we have to, when we find these eigenvalues, we will get lambda equal to few set of values. So these values should be substituted in the eigenvectors so that you will get few equations. From that equations, we have to normalize the eigenvectors. Then fifth step is we have to find the principal component. We can find the principal component by using yi is equal to E transpose, means we get few normalized eigenvalues. From the fourth step, we will get the eigenvectors normalized. From the fourth step, we get the normalized eigenvectors. So these should be transposed, and again we have to multiply it with x, so that you will get normalized equation again. And total covariance can be found by using lambda I is equal to lambda I by sum of n lambdas. How many lambda values you get, those many lambda values you are going to add it and divide. So this is the formula to find principal component analysis. So these are the steps to find the principal components and the total variance. So now let's solve the problem based on this. Let's see the first question. In this question, we are asked to calculate the principal components, and we are given the variance covariance matrix. That is, first step is already completed. So in the second step, we have to find, the second step will be our first step. That is, we have to find the eigenvalues. How can we find that? By using det of a minus lambda I is equal to 0. Let's consider this as a. Det of a is 5 minus 2 lambda 1 0 0. So this is our equation now. Now let's subtract a minus lambda I. We will get 5 minus lambda minus 2 0 7 minus lambda is equal to 0. Now we have to solve this det. Now let's consider this row. We are finding from this row. So let's now first element is 5 minus lambda. 5 minus lambda into, now let's remove these two, and we have to find this matrix det. 6 minus lambda, 6 minus lambda into 7 minus lambda, minus 2 into 2 is 4. So this, now next, minus of minus 2 is plus 2. 2 into, now let's remove this column and this row. is 2 into 7 minus lambda minus 2 into 0 is 0 plus 0 into something will be 0 is equal to 0. After solving this, we get the equation as lambda cube minus 18 lambda square plus 99 lambda minus 162 is equal to 0. This is our lambda equation. After solving this equation in the calci, we get the lambda values as lambda equal to 3, 6, 9. Now step 2 is we have to find eigenvectors. Eigenvectors can be found by a matrix of A minus lambda I into X is equal to 0. Now let's substitute A, lambda and X values in this equation. So we will get the matrix as minus lambda 2 minus 2 0, and the X will be x1, x2 and x3. How many rows we have, those many X values will be there. So is equal to 0. This one is, let's consider the first case as lambda is equal to 3. When we substitute the lambda equal to 3 in this eigenvector equation, matrix will be 2 minus 2 0 x1 x2 x3 is equal to 0. Now the equations will be formed as 2x1 minus 2x2 is equal to 0, minus 2x1 plus 3x2 plus 2x3 is equal to 0, 2x2 plus 4x3 is equal to 0. How we got these equations is, this row is multiplied with this x1, x2 and x3. Now to solve these equations, consider these two equations. Now let's write B, C, A, B. Now the A, quotient of x2 is B and quotient of x3 is C. So quotient of x2 is minus 2, which is B is equal to minus 2, C is 0, A is 2 and minus 2. And from the second equation, B is 3, C is 2, A is minus 2 and B is 3. So by solving this, we will get x1, x2 and x3. Now let's solve this. X1 by minus 2 into plus 2 is minus 4 plus 0 is equal to x2 by solving C and A we will get x2, and by solving A and B we will get x3. 0 into minus 2 is 0 and minus 4 is equal to x3 by 2 into 3 is 6 and minus 2 into minus 2 is minus 4. So the equation formed is equal to minus 4 is equal to x2 by minus 4 is equal to x3 by 2. Now by dividing by minus 2, we will get 2 is equal to x2 by 2 is equal to x3 by minus 1. First vector is equal to 2, 2, 1. So this is our first vector. In the same way, we are going to solve the second and third vectors. When we solve the second and third vectors, we will get x2 is equal to minus 2, 1, minus 2, and x3 is equal to minus 1, 2, 2. So these are the eigenvectors formed. Third step is to normalizing the eigenvectors. To normalize the eigenvectors, now let's consider the first vector. So to find the mod of x1, we are going to squaring all the three values x1, x2 and x3. So 4 plus 2 square is again 4 plus minus 1 whole square is nothing but 1. So root 9 is equal to 3. Vector will be 2 by 3, 2 by 3 and minus 1 by 3. Second eigenvector can be found by the same way. Second eigenvector values are x2 is equal to, we have minus 2, 1, minus 2. So minus 2 whole square is 4 plus 1 square is 1 plus minus 2 whole square is 4. Again we get it as 3. And now the second eigenvector is equal to minus 2 by 3, 1 by 3, minus 2 by 3. And now third vector is, we know that x3 is equal to minus 1, 2, 2. So it's 1 plus 4 plus 4. We get 3. And now substituting, we get the eigenvector 3 is equal to minus 1 by 3, 2 by 3, 2 by 3. So these are the 3 eigenvectors. Now fourth step is to find principal components. Principal components can be found by using yi is equal to ei transpose x. So ei is nothing but the normalized eigenvector. So y1 is equal to, even when we transpose it, we get 2 by 3, but rows will become as columns and columns will become as rows. 2 by 3, 2 by 3 and 1 minus 1 by 3 into x is x1, x2 and x3 variables. This equation can be written as this. After solving this equation, we get 2x1 plus 2x2 minus x3 by 3, and y2 is equal to minus 2x1 plus x2 minus 2x3 by 3. y3 is equal to minus x1 by 3 plus 2x2 by 3 plus 2x3 by 3. So in this way we got the principal components. Step 5 is to calculate total variance. This can be calculated by lambda I is equal to lambda I by lambda 1 plus so on up to n lambdas. Lambda 1 is equal to 3, lambda 2 is equal to 6, lambda 3 is equal to 9. Now PC1 is equal to 3 by 3 plus 6 plus 9 is equal to 3 by 13. PC2 is equal to lambda 2 is 6 by 13 and PC3 is equal to lambda 3 is 9 by 13. In this way we can calculate principal components and its total variance.